Right now, with every second that passes, with every tick of the clock, Tesla is producing 536 battery cells. That's not all happening in one place. It's distributed across an entire global network, which includes Tesla's Gigafactory Nevada, Texas, Berlin, and Shanghai. Together, they are pumping out batteries at a pace no other company on Earth can match. That number, 536 per second, adds up fast. It works out to over 32,000 cells per minute, almost 2 million per hour, more than 46 million every single day. By the end of a year, assuming full-scale operation, you are looking at nearly 17 billion battery cells produced. This isn't just a cool statistic, it's the foundation of Tesla's entire business model. Batteries are everything. They power every vehicle Tesla sells, from the Model 3 to the Cybertruck. They are at the core of Tesla's home energy products, grid-scale storage systems, and long-term goals for renewable energy. So, how is that even possible? How can one company operate at this scale with this level of speed while continuing to innovate on battery chemistry, design, and manufacturing? Because the answer isn't just about machines or materials, it's about control. And it's that control over every stage of the battery's life that gives Tesla an edge no one else has come close to matching. Every electric vehicle starts with a battery, and every EV company sooner or later runs into the same problem. There is never enough of them. Battery supply isn't just a challenge, it's the bottleneck that determines how fast an automaker can scale. Building more factories doesn't help if you don't have the cells to power what comes off the line. Most legacy automakers don't produce their own batteries, they rely on third-party suppliers like LG, CATL, and Panasonic. That only works until demand surges or material prices spike. At that point, the automaker is just another customer in a long line waiting. Tesla didn't want to wait. Early on, the company made a strategic decision to bring battery production in-house. That single move set Tesla on a different path from the rest of the industry. This gave Tesla three things no supplier can guarantee: speed, innovation, and cost control. Instead of adapting to what was available, Tesla started designing its own cells, building its own machinery, and investing directly in the infrastructure needed to scale. That meant faster product development, tighter supply chains, and lower prices per kilowatt hour. Now, of course, Tesla didn't start with custom-designed batteries. The original Roadster and early Model S used off-the-shelf 18650 cells, the same type you'd find in a laptop. And here's what those numbers actually mean. It's the physical size of the cell. 18 millimeters in diameter, 65 millimeters tall. The zero at the end just tells you it's a cylinder. It wasn't elegant, but it worked. Thousands of small cells wired together were enough to power a high-performance electric car. But as Tesla scaled, those cells became a limitation. So in 2017, the company moved to a new format, the 2170. This cell offered more energy density and required fewer units per pack. That meant simpler wiring, lower costs, and better thermal management. The 2170 became the standard for the Model 3 and Model Y and still powers most of Tesla's vehicles today. But then came the 4680. This wasn't just a larger cell, it was a complete redesign. Most cylindrical cells use internal tabs to connect the rolled-up active material to the terminals. Those tabs add resistance, generate heat, and slow down production. The 4680 removes the tab entirely. Without tabs, the current flows more efficiently across the whole surface of the cell. This improves thermal performance and makes manufacturing faster and more scalable. But Tesla didn't stop at internal improvements. We spend a lot of time talking about the future here. AI breakthroughs, EV innovation, missions to Mars, but let's be honest, none of that matters if you're waking up every day feeling like you've been hit by a truck. That's why I've been using 8 Sleep's Pod 4 mattress cover, and honestly, it's the best tech that I've added to my life that doesn't need software updates every week. It keeps you at the perfect temperature all night, adjusting to your body and even your partner's, so No more thermostat wars or sweating through the sheets like you're launching a rocket in your sleep. It also tracks everything: heart rate, breathing, sleep stages, even snoring, all without any wearables. And here's the part that really sold me. Since sleeping on the pod, I actually wake up feeling like a functional human being. Shocking, I know. The temperature control adjusts automatically because apparently it knows my body better than I do. And it even manages to keep both me and my partner happy, which is basically a miracle. But here's the kicker: it doesn't just sit there tracking your sleep and judging you like some passive-aggressive fitness app. No, the pod actually does something about it. Real action, real results, real REM sleep. Since using it, my sleep's gotten deeper, I fall asleep faster, and I wake up feeling like a functioning human, not someone whose soul is still buffering. So transform your sleep with 8 Sleep's Pod 4 mattress cover. Use my code TESLASPACE for an exclusive discount on your purchase. Click the link in the description, scan the QR code on the screen, and get the kind of sleep that makes you believe in the future again. The 4680 also unlocks a completely different way to build the vehicle itself. Instead of mounting the battery inside the vehicle frame, Tesla uses the battery as part of the structure. The cells are loaded directly into a rigid casing that doubles as a load-bearing element. This structural pack design improves crash safety, reduces weight, and eliminates unnecessary parts. The result is a battery that's cheaper to build, more powerful, and better integrated into the vehicle. And because Tesla controls the entire cell design process, they can keep refining it with every generation. To build batteries at the speed Tesla requires, the factories themselves have to be as innovative as the cells they produce. To do so, it designs much of the machinery in-house. This started with a project called Roadrunner, a code name for Tesla's custom battery production line developed at the Fremont factory. Fremont became the testing ground. It's where Tesla refined the methods, worked out the bottlenecks, and proved that its tabless 4680 cell could be produced at volume. Once the system was stable, it was ready to scale. That system is now in place, with Gigafactory Texas leading the way as the primary site for Tesla's next generation 4680 cells, with plans for Nevada to adopt production in the future. Tesla's battery lines aren't just automated, they are built for speed. Every part of the process, from mixing electrode material to winding, drying, filling, sealing, and testing, is optimized to move fast and run continuously. Humans don't do the work, they just monitor it. Machines handle nearly every step. Sensors and software track each cell in real time. If anything falls outside tolerance, it's flagged immediately and pulled for inspection. This level of automation allows Tesla to build at rates that would be impossible using conventional systems. This is what Elon Musk means when he talks about the machine that builds the machine. It's not just a phrase, it's a core part of the company's strategy, and one of the biggest reasons Tesla continues to lead on cost, scale, and speed. Producing batteries at Tesla's scale requires more than just factories, it requires a reliable long-term supply of raw materials. Rather than relying entirely on outside suppliers, Tesla has gone upstream. The company now sources key materials like nickel, lithium, and cobalt directly from mining partners, and in some cases, it's going even further than that. Tesla has secured the rights to 10,000 acres of lithium-rich land in the United States. It's also building its own lithium refinery outside Corpus Christi, Texas, the first of its kind in North America for an automaker. Unlike most traditional refineries, Tesla's facility is designed to use an acid-free process. That matters because conventional lithium refining relies on chemicals like sulfuric acid, which are energy-intensive and environmentally messy. Tesla's method reduces energy use by about 20% while also improving sustainability. The goal is not just to produce lithium, but to produce it better, faster, cleaner, and closer to where the batteries are actually built. This is vertical integration at the chemical level. It's about securing supply, reducing cost, and cutting out every layer of dependency possible, because the fewer middlemen there are between the raw earth and the finished battery pack, the more Tesla can control the economics of every vehicle it builds. Since its beginning, Tesla has focused not just on making better batteries, but on making them cheaper as well. At Tesla's Battery Day in 2020, the company laid out a plan to cut the cost per kilowatt hour by 56%. That's not a small improvement, it's a complete reset of the economics behind EV manufacturing. and Tesla is already ahead of the industry. At Tesla's all-hands meeting in March 2025, Musk announced that on a per kilowatt-hour basis, Tesla's 4680 batteries were now less expensive to produce than any of their competitors around the world. There are a few reasons for that. By sourcing raw materials directly and building out its own refining capacity, Tesla is protected from a lot of the price spikes and volatility that other companies have to deal with. Another is manufacturing scale. The more cells you make, the more efficient the process becomes. Every new Gigafactory spreads out fixed costs, tightens supply chains, and increases Tesla's bargaining power with suppliers. But the biggest lever might be the 4680 itself. Combined with structural pack design and simplified production lines, Tesla is aiming to bring battery pack costs down dramatically. A pack that might have cost $5,000 a few years ago could fall to around $2,500 at scale. It's hard to pin down exactly how much it costs Tesla to produce its batteries. The last industry report came out in 2021, and back then, the Cairn Energy Research Advisors report pegged Tesla's cost for its cells at $142 per kilowatt. This was a bargain at the time, with GM paying an estimated $169 and the industry average approaching $190. But times have changed, and the cost of battery production has gone way down over the past few years. By the end of last year, the industry average for EV batteries had dropped to $97 per kilowatt hour, with production costs in China being significantly cheaper than the rest of the world. That 2021 estimate of $142 doesn't account for another major part of the puzzle. In 2022, President Biden signed into law the Inflation Reduction Act, which created big subsidies for EV batteries made in America. As a result of that, Tesla receives about $45 per kilowatt hour back on each battery it produces domestically. And with international battery production costs down to about $100 a kilowatt hour, that means that Tesla costs could be as little as $35 per kilowatt hour, with the average cost for US EV batteries coming in around $85 after the federal subsidy. Tesla's battery output doesn't come from a single facility, it comes from a global network of gigafactories, each one designed to serve a specific region, and all of them connected by the same goal: scale. In Nevada, Tesla partners with Panasonic to produce battery cells. Panasonic handles the cell manufacturing, Tesla turns those cells into full packs. By 2020, the site had a capacity of 37 gigawatt hours per year. Last year, it produced enough batteries to power more than 600,000 vehicles. In Germany, Giga Berlin has been approved to double its battery cell production from 50 to 100 gigawatt hours per year. And that's just the first step. Tesla plans to eventually scale Berlin to 200 or even 250 gigawatt hours, which would make it one of the largest battery production facilities in the world. Tesla doesn't just build these factories to increase output, it builds them to reduce complexity. By producing batteries close to where the vehicles are assembled, Tesla cuts down on shipping costs, shortens supply chains, and reduces emissions tied to logistics. Each Gigafactory operates as a closed-loop system. Raw materials come in, vehicles go out, in between a tightly controlled, vertically integrated production line that's optimized for efficiency and built to scale. But not every battery Tesla builds ends up in a car. As production continues to grow, Tesla is expanding beyond vehicles and deeper into the energy sector. That includes products like the Powerwall for homes and the Megapack for utility-scale energy storage, both of which are already being deployed globally. If battery production eventually exceeds Tesla's own vehicle needs, those extra cells won't go to waste. They'll be used to support the grid, stabilize renewables, and store power at a scale few companies can match. This is part of Tesla's long-term strategy. The company is increasingly operating like an energy provider, not just an automaker, and batteries are the central product. Tesla's approach to battery manufacturing is also getting cleaner. The company is investing in dry electrode technology, a process that eliminates the need for solvents during electrode production. That means fewer emissions, less energy consumption, and lower environmental impact. The gigafactories themselves are also moving toward full renewable power. The goal is for each facility to run entirely on clean energy, turning the entire battery production pipeline into a sustainable loop. At full scale, every battery cell becomes more than just a power source. It becomes a container for stored solar, wind, and time, a way to capture energy, hold it, and deploy it wherever it's needed most. Tesla's battery strategy has redefined what's possible, but that doesn't mean it's easy. One of the biggest technical challenges right now is scaling dry electrode manufacturing. The process has clear advantages like eliminating solvents and reducing energy use, but it's still difficult to execute at high volume. And even with years of R&D, Tesla hasn't fully cracked it. To accelerate progress, the company has brought in industry experts with deep experience in battery chemistry and production. The goal is simple: solve the bottlenecks and get the dry process running at Gigafactory scale. But the technical side isn't the only hurdle. Gigafactories themselves are incredibly capital intensive. Each one requires billions of dollars in upfront investment, not to mention thousands of workers, regional permits, and complex supply chain infrastructure. It's a level of scale that only a handful of companies in the world can even attempt. Going upstream into raw materials also introduces new risks. Mining operations are subject to geopolitical instability, environmental regulations, and local opposition. It's one thing to source lithium, it's another to mine it, refine it, and ship it, all while keeping costs down and sustainability targets intact. Tesla controls more of its battery supply chain than any other automaker, but managing that level of operational depth across multiple continents is not simple. Every new site adds layers of coordination, oversight, and technical variation. Elon Musk has said it will take at least 100 gigafactories to transition the world to sustainable energy. Tesla has built the first few, which is a good start, but only maybe about 3% of the way there. Right now, every second, 536 battery cells roll off Tesla's lines. That number is staggering, but over time, it will look small. Because the plan isn't to build for today's demand, it's to build the infrastructure for an entirely new energy economy. That means more factories, more materials, more automation, and faster production at lower cost with cleaner processes. Every second, every cell moves Tesla one step closer to that goal, and the scale matters. These aren't just battery cells, they are the bricks of the electric age. The raw units of storage and motion that will power not just vehicles, but also homes, cities, and entire energy grids. Tesla isn't waiting for permission, it isn't waiting for the market to catch up, it's building the future the only way it can be built, with speed, steel, and precision, one cell at a time, 536 times a second.